Hello and welcome to Module 9 in our series STL2 with C++. In today's session, we're going to write code in order to generate multiple enemies using a linked list. Looking at the code we're going to write, we'll start by creating a new structure for our enemy bunny. This structure will represent a node in our linked list. We'll then proceed to create a new structure that will hold all the nodes or all the enemies, essentially our linked list. Now remember that each node in the list represents an enemy bunny. We will write a function to initialize the linked list. Remember, linked lists are all about using dynamic memory allocation. For those who are familiar with linked lists, you will know that we need to initialize linked lists so as to not have any issues with memory. For those who are not familiar with linked lists, I recommend you watch the module that is entirely dedicated to linked lists in my series on the C language. After initializing the linked lists, we will then proceed to modify our generate enemy function that will then allow us to generate multiple enemies, again using the concept of a linked list. And finally, we'll introduce a new function called bring in enemies that will do the following. Enable movement of our enemy bunnies across the screen from right to left. We need to make sure that if an enemy steps beyond the width of the screen on the left-hand side, then the enemy needs to be inactivated. In other words, the node that is allotted to that enemy needs to be nullified and the memory freed. So let's get started. Before we proceed, may I ask that you leave a like on this video, and if you're enjoying the series, do subscribe to the channel. It not only helps promote the channel, it means a lot to me as well, and keeps me motivated to create more content like this. Thank you. In your Windows search bar, type in VIS and then select your project from the list. Click once on it to open it up. Now we'll begin this session with our struct.h file. And we'll put in our new structure. That will be struct enemy. Now the members of this structure are going to be almost the same as our sprite structure. So we'll just copy these members and bring them in here. In addition, remember this is going to represent a node in our linked list. And therefore we will need struct enemy star next. And again, if you're familiar with linked lists, this will hold the address of the next node in the list. We're now going to put in a new structure. So type def struct. And this structure will have enemy type, enemy head, and star enemy tail. Okay, and this will be our linked list. Okay, so that's the first node and the last node. Now let's come to our main.cpp file, and we'll begin at the top. You can put in a semicolon here and then put in enemy. So this will be of enemy struct type now, and it will be a pointer, right? Because this is going to represent a node in our list. And then linked list type enemy list, right? Now we've got to initialize this linked list. So we'll put in a new function. I'm going to place it here. This function is not returning anything, so void. It's going to initialize the enemy list, init enemy list being its name, and no parameters coming in, so void. Within this function, we'll call memset, passing in the address of our enemy list. Setting everything to 0, size of, and that will be linked list. Okay. In addition, enemy list dot enemy tail will be set to the address of enemy list dot enemy head. So now we've taken care of the initialization of our linked list. Let's now proceed to modify our generate enemy function. Now you can ignore these squigglies. We'll see what to do with them later. We start here using the pointer we defined for our node, enemy sprite equal to, and that's going to be enemy star. Now we're going to call the malloc function. Size of enemy. We need to check if memory was allocated correctly, and that will be if enemy sprite is not a null, then we'll now call memset, passing in enemy sprite, setting the area of memory to 0, size of enemy. Then enemy list dot enemy tail, we'll use the arrow to access next, will be equal to enemy sprite. Similarly, enemy list dot enemy tail will also be set to enemy sprite. Right, so everything's been perfectly initialized now. Now we'll come to setting the attributes. So enemy sprite, we'll use arrow here, x will be equal to screen width, and then enemy sprite y will be equal to, and this is again as we did earlier, any random number within the limit of our screen height. So again the rand function modulo screen height. Now for movement, enemy sprite move x equal to, here we are going to use a negative and then call the rand function modulo. We know the number of steps should be between 2 and 5. So that is 5 is upper limit plus 1 to include 5 minus lower limit plus lower limit. And then on the y-axis, enemy sprite move y will be equal to 0. We want just horizontal movement. And then to reflect movement, enemy sprite x plus equal to enemy sprite move x, and then enemy sprite y plus equal to enemy sprite move y. Right, now remember we are generating a new enemy or a new sprite using the memory allocation function. We need to also set enemy sprite arrow texture to enemy texture, right? And we need to capture the width and height of this sprite. So we will call STL query texture and send in enemy sprite texture and null for our format, null for the access, and now we'll capture the width and height. The width we will capture into ampersand enemy sprite width and ampersand enemy sprite height to capture the height. One more thing we need to do is enemy sprite next we will set to null. Remember, when we have a new node in the list, we need to set next to null. Until and unless we have another node, and then we can have this one point to the next, right? So the next then will have the address of that new node. All that is left now is the timer. So timer equal to, we call the rand function modulo 60 is upper limit plus 1 minus 30 plus 30. Okay. Now we do not need all this code. Okay, so what we do is, I'm just going to delete it. You can comment it out if you like, but then it gets very cluttered. So I prefer that you delete this. Okay. And make sure we have the correct number of closing brackets. That will be 3 closing brackets, right, that you need to have. Okay, so that completes generate enemy. The next thing we need to do is introduce our new function, and I'm just going to place it above this one. So this will be void bring in enemies. No parameters coming in, so void. Now here we will have variables enemy type pointers, so star en and star previous. These will help us move through the linked list. We'll set previous to ampersand enemy list dot enemy head. Okay, so that will have the address of the first node. Then we have a for loop for en equal to enemy list dot enemy head dot next en not equal to null, which means as long as we have not reached the last node in the list, en equal to en next. Again, this is going to help us traverse the list. Then we have en x plus equal to, so this is going to help movement, en move x, right, and en y plus equal to en move y, right? Now we've got to check for the enemy moving beyond the left limit of our window. So we'll put in an if statement here. So if en x is less than, the best way to do it is negative screen width. Okay. So if we are moving beyond the left limit of our window, we check if the enemy is the last node in the list, so dot enemy tail, then we set enemy list dot enemy tail to previous. Okay, now if it's not the last node in the list, then we set previous next equal to en next. We're getting ready to free the enemy node that is moving beyond the width of the screen. Then free en and en equal to previous, right? Now if it's not moving beyond the left side of our screen, then we can just say here previous equal to en, and the for loop continues, right? Okay, so I hope you got that. That completes our bring in enemies. Now we need to call these functions. So come to your main function. And first of all, we do not need this statement now. Remember, we are creating the new sprite using dynamic allocation of memory, right? So you can either comment it out or just delete it. The next thing is to call init enemy list. So just here, init enemy list. Now coming further down, we do not need this, right? So again, you can comment this out if you like, or you can just delete it. Come further into the while loop now. And after this, we will call in bring in enemies. Now we do not need this code, so we just delete it. Now we've generated the enemies. We've also taken care of movement of the enemies across the screen from right to left. And we've also taken care of when the enemy moves beyond the left limit of our window. But what about drawing these enemies on screen? And so we'll have another function. We'll call that blit enemies. And I'm going to put it just after our init enemy function. So here, void blit enemies. And within this function, we'll have an enemy type variable, so pointer e. And then we'll have a for loop for e equal to, that will be enemy list dot enemy head dot next. This for loop will continue as long as e is not equal to null. And so we move through the list. E is equal to e next. And we'll just call the blit function here, passing in e texture and then e x and e y. So I hope everything's clear. We need to call this function now. So come back to the main function and let's call that function here. Right? That's it. So let's run this now. And there you have the enemies appearing on screen, right? But of course, again, the egg is moving behind these enemies, right? So in the next session, we'll see how to kill the enemies on contact. That is when the egg comes in contact with them. I leave you to play with this now. This ends our session for today. Till the next session, take care. Bye.